Hey, what if I tell you you can create a whole system architecture, load test it, and scale it to a million users with just a prompt? Doesn't it sound amazing? So that's exactly what we are trying to achieve here. The problem we are solving is that you can write code blazingly fast nowadays, but the system architecture still remains a problem. So in this platform, this is the landing page, and if you're a developer, you can just simply drag and drop the architecture nodes like this and change their various attributes according to your needs. For example, this is the payment gateway. You can change the label, the request per second, latency, concurrent request, timeout, and a lot of other stuff. Retry strategy, fixed or exponential. So we also have some pre-built templates for you to get your hands dirty with this one. If you just hover over a particular widget, you can see what the node says, like why is the node being used. And this is the simulation page. I will explain more about this later. This is the simulation data we will get after simulating it. We also have an AI system architect, which you can just write in a prompt what are your needs, users, and stuff, and it will generate an architecture for you. For example, I am a non-tech guy. I don't know much about system architecture, and but I still want to build a application for like 10,000 users, like create a delivery app for 10,000 users. Just click on generate architecture and it will generate the whole system architecture for you. So in the backend, we are using Gemini 3.1 Pro Preview because it has exceptional reasoning capabilities, which is exactly what we need for this architecture design and pinpointing what the thresholds would be so that we can fix the bottlenecks. After fixing the bottlenecks, the architecture will, of course, become better and better as you scale the users. So the backend is deployed on render free tier, so that's why it takes a little bit of time in generating, but it will get there. Okay, so here we go. These are the strategy pointers, the expected capacity and stuff. So let's apply and simulate this in the canvas. So this is the delivery app it built. Two channels for notification services, one instance each for delivery and authentication and stuff. So in this simulation page, you can simulate external and internal traffic. For external traffic, we are using Locust, uh, mock, um, a mock traffic generator, Python package, and for internal load balancing, we are for internal load generation, we are using Poisson distribution to distribute the load evenly. For the sake of this demo, let's use some internal traffic of request per second 100. We can choose the pattern to be wavy, like request increase a little, decrease a little, spike as in it increases a lot faster in a short period of time, then goes back to normal. Like it just implies from the name itself, ramping and constant too. Let's take the pattern wavy, RPS 100. We can also apply scenarios. These are some common scenarios that we have chosen, which happen in the real world architecture. Your DB can go down, partial outage. There are a lot of stuff that can happen. So let's choose DB saturation here. Let's apply the scenario. This scenario will be affecting our database node, as you can see. Let's start the simulation. So now the simulation. So the API key was a little overused. So I'm now changing the example and starting the simulation again. So after starting the simulation, the AI has identified three bottlenecks. One is a normal warning level threat. Other two can go down in a real case scenario if this type of DB saturation happens, and this is a system architecture. So let's try optimizing this architecture with the AI optimize. Okay, so here is the matrix dashboard. Here, as you can see, these are the nodes in the architecture. If you hover over them, you can see the expected input and the expected output in the JSON format. And this is the health, like this API gateway 60% healthy. Now these are the identified bottlenecks for the AI. Let's try optimizing these. Okay, so these are the bottleneck insights. The database is in excessive queue depth. The changes proposed are increasing the instances of API gateway and the max connection in the database, and also adding a replica. So let's apply these changes. Okay, so as you can see, it has added replicas and the connections have also been increased. So this is how you can iteratively update your architecture while scaling users.